Hey, I'm John with New Media Nashville, and I just did this lighting and projection project for an event called Nashville Drone. Uh, and also, I'm in this boot camp with the Immersive and Interactive HQ, where my project perfectly lined up with having to build a lighting controller. So this is my sort of documentation slash walkthrough video of my project, but I'm going to split it up into multiple videos for each section so that it's not too long. In this video, I will do the room layout and the UI. But this is the high level overview of the project. We had a com section, a generation section, and an out section. This room layout, you can see it's locked, it's not doing anything. This was me setting up how to think about the project. I first had to visit the site and find out what lights they had and how they might be laid out. And this ended up not being perfect, but it was pretty good. Uh, Basically, they had a suspension thing. I forget what they're called when the lights are suspended from the ceiling. But along that bar, they had nine spotlights. And also on that bar, they had four moving lights. Uh, but you can see there was two different types of moving lights. And I put some info in here for myself about each light, their model, and how many channels they had, and their DMX address. Uh, so the production person in charge of production at the venue, uh, he had a spreadsheet of all of the DMX addresses because he has a lighting controller and had to know what those were. So I made sure to get those from him, also the models, and he gave me a couple of the manuals of the lights, but I also had to Google them anyway. So as long as you have the model of the light, you can Google the manual and figure out um, what each channel does. Uh, so yeah, we had so this is how the room was set up. There was going to be instead of a stage that would be up here, they wanted to use the middle of the room where they would have basically these two tables. The idea of the night was to have a continuous sound. So one performer would be here, and then before they end, the second performer would be setting up so that there's a seamless transition between them. And the control room would be upstairs back here. So there would be, along this bar, there'd be nine spotlights and four moving lights. And then we could have floor lights, two on each side. And then there were two more moving lights we could have up by us. So this was me planning out sort of how I would lay out the room and keeping track of what the DMX addresses of everything were. But now let's get to the UI. I will just walk through what it does. So this is like a presentation of the final product, and then in the other videos, I will actually break down how I did everything. So this is like the front end. This is what I was looking at uh, during the event. So up here we have a menu of pages of what you can control. This is the color section. So you see I have three modes for the color. I called this one for all because it's one color controls all the lights. And this is my little previs that will make sense later when I show you how I did it. But this is the previs of the lights, and basically I could just move these sliders to control the red, green, and blue channels of the color of the lights, and this would go to all of the lights. And then I had this, what I called an ambience section. This one's a little more in depth. So this whole thing down here with all these colors, this is a component that Aristotle showed me about basically color palette selection. So I didn't make this, but I did have to go into the component and modify it so that it would look better in the UI. For those of you using TouchDesigner and you get an external talks or something, don't be afraid to like go in there and resize the components and try and figure out how things work. So yeah, I basically just had to like stretch all of these. And I guess if you're making components to be put out, also make sure everything's scaled to the parent component so that it does work everywhere. Uh, but how this worked was you could pick a color palette and then uh, it would basically use that color palette in these. And this will make sense when I go into the how I generated the color of the lights. But basically, you have this like ramp with three colors on it, and then you sample where the lights are to get their colors. So that's why it's like that. And then I had essentially, I think it was three different ramps or maybe four. Looks like three different ramps for this one. So the same colors, but they'll be moving in a different way. And you could see the intention was that the lights would be changing color in a different pattern. And the ramp is being animated by ABS time. Uh, if I could do it again, I had meant to add I guess, a slider to affect how fast and how slow it went, but I didn't get to that. So we have, yeah, that one for all mode, the ambient mode. And last one, my favorite was this camera mode. So I made these little Raspberry Pi cameras, which were kind of the star of the show. Uh, let's see. Oh, there is a bunch of delay on them, so that's gonna happen. But yeah, basically networking. Yeah. See, now I don't know which one moved because I had two. Looks like it was this one. But yeah, I had these cameras, and this mode allowed the you see the same way I said that these were like sampling the positions of the lights from this image. You could basically do that with any top. So I thought, why not do it with the camera? And so this allowed us. I guess I can explain this here that it created this cool mode where I didn't really think when I was making this. I didn't think about how dark the room would actually get overnight. It was from 6 p.m. to 12 p.m. And I just knew that I wanted to be able to like put a camera feed of the performers in the projection. But because it got so dark, the only light in the room was the lights that were on the performers. And so the camera was also looking at the performers, and they were colored by the light. So it ended up creating this feedback loop where the camera is using the color from the lights, and the lights are getting their color from the camera. And it created this weird sort of like system that determines its own color. It was very interesting feedback loop. Uh, but I'll come back to the cameras when I get to the video controls. That's it for the color section. Then you have the dim section. I just had a one for all where this knob just dims or brightens all the lights at the same time. The same concept of sampling UV positions. And then same concept of an ambient mode. Um, this time I had four different ramps, and I had them in a switch where you blend between them, which was nice. And then I had a lower bound. So basically, the ramp is using the alpha of the color. So I just have to go in and raise the alpha to say the lights cannot dim below this point. I did not add a UI for the high band, so over the night I had to go in and manually do that. That's why it's not bright here. But another cool thing here is I added reverse. So they're also being animated by ABS time. So all I had to do was say like when this button gets clicked, uh, a constant will either be +1 or -1, and the ABS time is multiplied by that constant. So go -1 or +1, and whatever mode you're in just goes the opposite direction. So that was cool. pan and tilt. You'll also see that as I moved through these, because I kind of made these in order for the most part, I got better at making the UI and the previs like over time. Let me go back to this. I guess, oh yeah, I should say on the technical side, one downside here is that whenever you press a button, it immediately switches to that mode. So there's no like preview of what to do. As soon as I go to ambient mode, this is what the colors are. When I go to one for all, this is what the colors are. And let me go back to all the way up. So these lights, the colors are previz. Like I just attached them to the colors that they are representing, which was interesting. But pan and tilt, pretty self-explanatory. The lights, you can either pan them up to like 540, I believe it was, and tilt. I don't know. I don't think these numbers are right. This was my guess, but I thought that lights could go between like 270 degrees. So I just thought like zero would be straight down, straight up, and then. But I don't think that's exactly right. It was more of a, the visual help more than the numbers. But yeah, like I said, there were like nine spotlights. Those don't move, and then there were a total of 10 moving lights. So you could pan and tilt each one, and they worked really well. I'll talk about this more when I can break down the project, which now I'm realizing how long that'll be. See if I get to it. Uh, the some of the lights were mapped wrong, and assuming that it was my error and not the sheet that the production guy gave me, I if I could redo this, I would like to do all of the mapping of bindings automatically in Python because it was extremely hard to debug where things got their bindings from in real time. Like if it's the master binding, then it doesn't say what's referencing it. So I couldn't find where things were like bound to it to figure out why they were wrong. Uh, so when you have to go through and manually drag things from custom components to bind them, you kind of get lost in a big project like this. But but that's basically self-explanatory for pen and tilt. I could show you how they are prevised again. You see they're changing. Uh, Now I think this at least is the previs I'm most proud of. This, you have a zoom and focus, and I used a blur to emulate the focus, and obviously size to emulate the zoom. And yeah, this worked for the most part. Self-explanatory. I just since they're attached, I decided to use a 2D slider, but fundamentally works the same as pen and tilt. And I didn't actually have time to make an audio reactive mode, so I like had something there, but it was too risky to use it, so it didn't work. Or I didn't even try it on site because there were so many things going on. I didn't even ask for an audio input. Uh, so yeah, no audio reactivity with this one. The lights also had this option to frost, which was just an on and off thing, and it basically just made the light very diffuse instead of focused. So nice for like a light wash. They also had a prism, and actually, like I said, I got better at the previs as I went along. So maybe this is actually the one I'm most proud of, because when you press on here, it also turns the display option on for this. It'll make sense when I go into the how I made it, but that's just a container that I can turn the display on and off. And yeah, this is what the prism looked like on the lights, so you could rotate it. And yep. Also cool, they had a fog machine. And this was cool. It kind of felt like magic to be able to control this fog machine from across the room. But everything was DMX on one universe, so if it has DMX, then I could send it signals. And this was the camera controller, so I could switch between the I had two cameras. I could switch between the cameras. I exposed some of the controls uh, to affect the image in real time. And I had these different presets on a composite that were very reactive to whatever I did with these and how the camera was placed and how the lights were. Uh, so yeah, these cameras were very useful. And the last part of the UX was this panic button I added at the last minute, which basically this is attached to the active button on the DMX out. So I thought if something's going wrong, I should just at least stop sending DMX signals. Uh, this I feel like this is not a true panic button because uh, the even though I stopped sending signals, all the lights would stay on. Whereas when you actually unplug the DMX cable, everything actually powers down. Uh, so that was an interesting sort of caveat, but I never had to use it. But I just thought I needed some kind of like, what if something goes wrong? Just stop everything button. So yeah, that's at least a walkthrough of the UI, and for the most part, everything worked well. Like I said, there were some wrong mappings here and there, and also the lights worked in a weird way. For example, the actual like lights themselves had a strange interaction between Prism and Frost. Like if you turned on Frost, it automatically turned off Prism. And since there wasn't two-way, then this would no longer work. So yeah, some strange interactions like that. But overall, all the important things worked. I was able to move the lights, change the colors, dim, and yeah, I was very happy with it. Continuing over my project for Nashville Drone 2025, we'll now move on to the UI. So go into the UI component. I used a lot of widgets, so you need that basic widgets thing. And this is the DMX controls. So top level view, uh, I have my page select, and this is attached to a chop execute script. So I guess we should start by going into the page select. Or no. Oh yeah, so there's nothing in it. This was actually just a radio button, and I just called it page select. And I just referenced the top, or I referenced the chop that's inside of it for this chop execute. And basically, so this is how you script uh, how to have different pages in a UI. Is you need a select comp, and in the select, it has a field for what panel do you want to be showing. And so on this radio button, the output is just the number of the radio button. So you basically just say like, oh, if it's zero, then that corresponds to this panel down here. You know, show that panel in the select. Uh, so you just have as many if statements as you have panels, and you separate them out into different components so that you can select them individually. But yeah, so all that is a radio button and a chop execute plus a select comp. And let me double check if there's any like interesting things about how to write it. Uh, no, I don't think so. Yeah, pretty standard. Um, I guess if you've never done it before, the only thing you have to know is that all of these need to have their display off because they shouldn't actually be seen in the UI. If you have it on, then they'll be there and the select will be there. So all of these need to be off, and just this is on, and just this is on. Oh, I guess this is an interesting thing to talk about. Is laying things out, um, I have a small background in graphic design. And in graphic design, there's this concept of grid layouts. And so I tried to emulate that with this, and there's probably a better way to do it than manually, but this is at least a step better than actually specifying pixels for everything. The idea is, for example, this 2/8 idea is whatever the size of my parent panel is, I imagined a grid where it was split into eight, uh, or I imagined a grid where the height was split into eight sections. And I said, I want this to take up two of the eight sections. And for this one to take up, I guess I didn't have to put it on this 'cause it takes up the rest. I probably put it on these, yeah, because this matches its size from the other one. And so all of these take up six. And so this will also be familiar to anyone that's ever worked with CSS. You also have to specify like box sizes in terms of grids. And so that's a very easy way to keep everything sized correctly when you have a bunch of different components. I'm going to definitely continue this method, but hopefully I can find a less manual way to do it. But yeah, that was an interesting thing. Size everything to the parent panel and then multiply it by a fraction to think of it as a grid. Uh, this video I'm now realizing is going to be very long, so let's try to power through. Uh, so yeah, high level, these are all the different pages. You go into the color component, and it has the same concept of, since I had different modes for the color, you also have select comp that goes through the different modes and chop execute that scripts it all. Uh, oh yeah, so in the higher level one, I scripted them all individually because they have different names and you have to. But along the way, I figured out that if the only thing that changes is a number, then you only have to write one uh, expression. You only have to write one line where you just use an F string that inputs the number for you. And you just have to make sure that each of these names has a number that corresponds to the radio button value. So hopefully that makes sense. The first button is 0. So inside the script, it says you control mode and the value is 0. So control mode 0. Yeah, you'll immediately when you do it, you'll just see it. If you try to debug it, it comes out as a float. So you need to make it an integer for it to work. But yeah, same thing there about different scripts. Only extra thing here is have this previs going. And so there's like an extra top layer container that is both of these together. You already know about how to align things. Yeah, I think that's it. Same situation here that, oh no, that's right. Man, yeah, I had an individual control mode that I decided not to use. One for all color. This is just a widget with three sliders. Yeah, nothing interesting there. This is the component that Aristotle showed me. Maybe I could find what it normally looks like. This is what it came as. Uh, so all of this is just, I didn't have to build any of that. It just does this. And what I did was go in there. and turn off the display flags of things that I didn't need, and change the size of the components to uh, be stretched to the parent. And and then I pulled out the colors of this and used it somewhere else. Container for the blend mode, regular widget slider, and I used an op viewer to see where those ramps are. Uh, I go delete this. Uh, color control mode two. Oh yeah. So yeah, there's actually nothing to go on here. It's just selecting the output of my. It's just selecting the output of my FX like area, uh, and it's inside the chop execute script that it goes in and changes the mode where the colors are actually being generated. And this color previs is also pointing to that output. So it automatically, everything else automatically changes, and the only thing I need to show here is like what the camera is seeing. And I believe this, I just disconnected this. This was going to be like an audio reactive mode, and I decided not to use it, like I said. So yeah, I'm trying to go through this quicker now because I'm realizing how long everything will take. So hopefully everything makes sense. That was colors, and now we can go to dimmers. Dimmers, everything worked exactly the same. I think nothing new here. Same chop execute with the select, and you put the container so that you have the previous two. You name them with just a changing integer. Uh, use widgets and op viewers to see what you're doing. Same here. Yeah, nothing new here. Uh, pan and tilt controls. Uh, yeah, this was also going to be like in audio reactive mode or something, or an ambient mode. Decided not to do that. But inside the controller, I guess this is where it starts to get interesting. Like I said, I got better at UIs as I went along. So in here, um, I did not use many callbacks. I learned how to do that later. And this is probably too specific to really warrant explaining much. But I'll just start by saying what this does is it goes into this is a field comp, uh, and I just had to change it to the right digit because there were things inside of it that were dependent on its number. So I used a field comp. There's probably a better one, like a better thing to use. I was just trying to work quickly. And the way a field comp works is you have this string, you're able to like type on it and it immediately writes it as text. Uh, but I wanted all the lights to happen automatically. So this is just a text that's usually called string. And in here, the text is referencing string. So I added the expression that will change the text based on uh, the parent's digits, right? So it's just light with the parent's digits, -8 to because of how I had the lights named. Some of them were spots, and then I had to add an expression or an evaluate det and call that string. So that's all that is. Probably I don't know if I overcomplicated it, but yeah, that concept was like the start of me realizing how to use replicator callbacks uh, to script things that happen inside of each clone automatically. So when I get to the other components, that becomes way more powerful. And then, yeah, like I still had to go through these and manually map the bindings of the UIs. Uh, But yeah, that's all that is. Just more widgets, uh, zoom and focus. Same concept with the chop execute and the select. Didn't use that mode. Go into here, another replicator situation. And same thing with the fields, although this time I figured out how to use pattern matching. So this asterisk means look for any operator name field and followed by any other text. And I did that because I know there's only one in there. So yeah, I also used a field, although actually I think I added stuff to this one. So all of this up here is field, like comes with field, not this. And this is the little previs I added to it, just using a circle. Uh, and I selected this from up here so that I could lay it out the way I wanted to. And yeah, this is just a circle, and I mapped the focus to a blur here and the size to the size here. One, I guess, caveat if you're trying to do this yourself, the first thing I tried was raising the filter size, and that is extremely CPU intensive. I didn't realize. So now it instead increases pre-shrink, which does not require as much CPU apparently, and has the same effect. But yeah, that's the only interesting thing there. Other than that, all of that happens automatically, and then but I still had to bind them manually. Uh, Frost, let's see, same setup widgets. Did I do any replicators here? This is I added my first one, is I realized I could bind them automatically uh, by uh, using the digits idea again. So this was my first time actually saying, do I have to manually bind all of these buttons, or can't I just write in a binding expression? The reason why I wasn't sure I could do it is because if you go to a regular uh, like binding expression and try to write like Python to it, it like doesn't work. I guess that I don't know a good place to actually look at that to show you. Let me try this. Uh, yeah, like if you just try to write regular Python in a binding expression, it doesn't work the way it does here. Uh, and yeah, I just messed up my program now. But uh, so yeah, when well now it's gonna be hard to show you. But I thought if I tried to write an expression into like a Python expression into the binding expression, I didn't think it would work. So that was like a realization that you could use F strings in the bindings. Uh, so that'll be messed up now, but I'm not gonna save this project. Um, Prism controls. I guess this is probably the more interesting previous because or maybe it was the other. I thought I used I thought I used way more bind. Oh no, it's in here. This this is where I was like, well, now that I could do that, let me just go ahead and bind everything automatically. And it's very messy because I didn't name things originally with that intention. So I had to, go through and say, oh, it's inside this operator, there's this operator, and inside that one, there's this one, and inside that one, there's this one, and I want you to bind this parameter of it. So there's probably a way more smart way to set that up, but the concept is the same as realizing, oh, I can actually just make all that happen automatically and not manually do it. Uh, and also this concept of this display flag is also bound to the button. So that's why all the sizes stay the same, but if you press the button, the display flag goes off. I thought that was a cool thing. So yeah, nothing else to say about that except for this was a big revelation of how to use replicated callbacks. Almost done with the UI. Fog controls, super simple. There's only two channels, just widgets, video controls, yeah, up viewer to see what's happening, just a bunch of sliders and button radio button widgets. Nothing interesting there. I guess I've been glossing over how I've had the layouts, but it's the same thing about the grid of since these are scaled to like I'll just talk about these since I'm here. These are scaled to their parent. They all work the same way. So this is their parent, which it's scaled to its parent. So just to make it make sense, the larger like UI, that's 19 by 20 or 1920 by 1080. And so that's the parent of this saying, give me that width and 6/8 of that height. Now inside this, now it's using its parent's width and height. So give me half of that width and just its height, because these will be side by side. And that goes all the way down of saying like, okay, these are all going to be arranged vertically, so make it 1/8 of its parent's height, uh, and so on. So all of them work that way of having everything scaled to its parent all the way up and all the way down, so that everything lines up nicely. But it's still very manual, having to think about what fractions you want. Um, but that's video controls. Last was panic. And like I said, this is just bound to DMX out. So yeah, I think that does it for the UI. Hopefully it was comprehensive. I started trying to rush through it, but I think I covered all of the like important concepts at least. So yeah, next I'll move on to probably the display section. This time I will be going through the output section of my Nashville drone 2025 project. So in the output, there's only display, and I was trying. So there was a UI and a video, like a projection output, and I was trying to figure out how to do the single output thing. This was me trying to figure out if it was because my laptop resolution is different than the projector. But no matter how I did it, I think I followed all the right settings of the video. It just would not do the two screen thing. So I ended up doing what you're not supposed to do, and I had two windows. But this actually ended up being better. So I'd be curious to see what Elbers says about it. On my UI window, I just made sure that popped up on my laptop as a perform mode. And on my projection window, I made sure that popped up on the second monitor as a separate window, not perform mode. Um, and I also disabled VSync mode, which I think is the main concern about having multiple windows, is that they would fight for VSync. So I didn't have any problems. I just turned it off. I still don't quite know what it does, like why that would be a problem. But the reason why this ended up actually being better was because um, I knew that I would sometimes have to close the UI and go into the code and change things. And I didn't want that to close the projection at the same time. So I wanted the projection to stay up even after I leave perform mode. And that's exactly what this did. So it feels like a good method for me. Um, I guess last thing I'll add is I deleted it because it's. Um, I guess let me explain this. This TD remote thing is super cool. Um, yeah, basically, I would have had a select comp. Like I would have basically I had this right, and I would reference this here, and then connect it to my like phone or iPad on the network, and there's a phone app that it connects to, and it works amazingly well. The problem was that uh, basically my project kept crash. It didn't keep crashing. It was like one time on my phone, I accidentally like closed out of the app, like fully closed it down while the project was still running, and it crashed the project. And then uh, that's how I noticed that inside your project folder, TD Remote makes this like cache folder of stuff that it has to keep track of. And I think I changed that or got rid of it, or a new one was created when I changed the address or something. And then from then on, it would, I guess, not have the right files it needed. And like every time I tried to open my project, or like anytime my project would crash, I was like, I don't know what would be causing this. And then as soon as I got rid of this, it no longer crashed. So basically, I'm like, I want to use this. It actually works amazingly well. Like whoever made it is a genius, but it was too risky that like there's a risk that it would crash my project. Uh, but that was the other thing that would have been an output is like this TD remote section, and I just had to delete it because yeah, my project kept crashing. But yeah, that's it's a simple setup for the output. Continuing to go over my Nashville Drone 2025 project. Now we're in Gen, and now I will talk about the lights. This is the obviously the crux of the project, so it's probably going to be the longest section. But high level view of Gen, there's lights and video section, so we'll go over the video part uh, later. But inside the lights section, so this is what it looks like. It's very messy. I was figuring things out as I went along, and I would not this I don't think this is like the best way to do it. But it did work. So I guess we should start with UV positions because this is sort of the central concept of how this worked. Is how to explain. This part is I don't even know if it's like the smartest way to do this, but I just needed a bunch of rectangles laid out the way that my lights would be laid out in the room. Um, but this gave me a headache that my lights are named spot 1 through 9 and then light 1 through 10. And the rectangles are just named 1 through 19. And so they weren't mapped one to one, and that caused some headaches. But the overall concept is like once you have this top where each square represents your rectangles, and I guess I should also say um, I had this mapped so that each rectangle was 1 pixel. So yeah, I made the top that is 9 pixels by 9 pixels, and I made each rectangle 1 pixel. I did this because uh, I guess maybe it's not necessary, but it seems like it makes it simpler to think about positions as being a point instead of an actual square of multiple points, you know? So like when I'm thinking about positions, it's single digits instead of like fractions of the aspect ratio, you know. So I imagined a grid of 9 pixels by 9 pixels, and then just arranged my squares where the lights would be. And um, I will talk about this parameter execute in a second, but the main concept here is that, uh, oh, I guess I'll talk about the execute in a second, but the main concept of sampling the UV positions is, actually, am I skipping something? Hold on. Outship parameter. Okay. I'm sorry. I'm like remembering what I'm doing as I'm doing. So what you do, all of these rectangles are being referenced in the parameter chunk. So you can do that because they're all the same name, and you say like this array 1 through 19 reference all of these. And then you isolate what parameters you want, center X and center Y, these. And so this would just give you a chop that has all of the X and Ys. Um, now, uh, what you want to do is say, now that we have the X and Y position of every rectangle, you want to normalize those from 0 to 1, because that's how UV positions work. They go from 0 to 1. And I can talk about how this is used later. Maybe I shouldn't have started with it because it's kind of confusing without understanding where it's going. But essentially, now I just have a chop that has the positions of all of my lights theoretically arranged from 0 to 1. And this is a shuffle that just sequences them into channels, because later we're going to reference each light by, or this does allow you to reference each light by its sample number, instead of having to reference two channels every time. You just say, what's the X of light 1, which would be sample 0, you know. So yeah, that's probably way more confusing than it actually is, just because you if you haven't used this, you don't know like where it's going. I'm trying to remember what this is. So this was, I didn't know if, like, for example, this light in my diagram is light 5, but I on site, if the uh, if light 5, like the one that I have, like its DMX address is a set number, if that DMX address is actually going to be over here when he sets it up, then it's going to mess everything up if the lights are in the wrong positions. So I have some of these bound so that I could affect them outside. But even if I didn't, I actually did have to come in and like do some of them manually. The point is that this table is referenced in a lot of places, and these squares are referenced in a lot of places. So I had a script that said, if any of these values change, go through every rectangle and update its position so that everything stays aligned throughout the project. Uh, is there? I'm trying to think if there's. I'm trying to see if there's any like Python techniques in here that are interesting. The positions come as like rectangle one colon x. So I had to split that because yeah, it's just naming things. But yeah, that's why I had that. So yeah, hopefully this will make sense later when we actually use the UV positions. But this was just setting up, how do I use a top texture to get the UV position of every light? And how do I make sure that if I move the lights, everything will stay updated throughout the project? That's what this is doing. So now it'll make more sense after we go through color modes here. So like I said, there was an individual color mode. This basically used the same thing. And here's an example of where this script would matter is I basically just copied over, I believe. Yeah, I basically like copied over this whole replicator situation, but used the select from the UV positions because all of these will be named the same, and said if any of these values change, run my update rectangle positions thing. So this has to be present everywhere that this whole situation exists. And so if I change the values in the UV position, the original, it'll update it everywhere that this whole thing happens. Uh, so this individual control mode was an example of it. And in case you wanted an individual control mode, all it is, I just map the color of each one. And so it's going to be that color in that UV position. One for all mode, same thing, except all you need is one color for the entire texture. Ambient mode, we have these ramps. Um, a ramp is you add points here, and you can change the color of each point, and then it does its thing. Animated with ABS time dot seconds. Anything interesting here? So ramps have a table of these things that you make, and it says where it is on the strip and what its RGBA value is. So since I wanted all of these to be the same three colors, I this is a constant where I can change the colors, and I said if the values of this constant change, then go through each ramp and change its RGB values to that. So that's how I can keep these mapped together. And then, yeah, switch to go through the three modes and blend them. That's all that is. I think I didn't expose this in the UI, but I did say this ABS time dot seconds. Uh, you can multiply it by a constant, and that'll be its speed of change, basically. Uh, Camera mode. Yeah, the cameras are still going, and so I just have the select of that out, and then I down-resed it to my 9 by 9 texture, and just have that going out. And then this audio reactive thing ended up not using. But so have those going through a switch. So this is what changes when you change modes. You go through each of these in a switch. And here's where the UV position thing starts to make sense. There's two ways to use it. One of them is a top. So the top was basically for my visualizing. Is whatever I have going here, I can have a comp and just multiply the colors by my UV, texture. And so now the only things in color are where my lights are. So that's basically how all of my previs things work like this. Is and again, this is selecting from the UV positions thing. So if I have to move the lights, it'll be automatically updated. So that's basically just for previs. Um, I also so whenever I would switch between modes, all of the colors would update really quickly, like immediately. And I was wishing that there was like a filter top, the same way there's a filter chop. And then I realized you could go top to chop, add a filter, and then go back chop to top. And so that's all that is. Hopefully that makes sense. Make different modes. You can switch between them, use the UV position things to make a previs, and then the out of this is just going to be a top with the correct positions. And I guess I can go ahead and explain the whole UV sampling thing before we move on, because it'll work the same for everything else. Like the reason why you do this, so technically I didn't need to do this previs thing, because what you actually want is whatever your texture is, you're going to do a top to chop of it, right? So you do top to chop of this, but the second input here are your UV sampling coordinates. So remember when we got the like the pixel positions of all of these, and then we normalized it to 0 to 1 so that it would be our UV positions. Okay, now we have, and we made it multi-sample instead of multi-channel. So we just have X and Y or U and V. And these are the positions of all the lights that exist, which are also pixels. So it's like this light is for this pixel, et cetera, et cetera. And so now when you go top to chop and give it positions, it's only going to give you the RGBA values of these UV positions. So now my top to chop is RGBA, where the sample number is the light, and it has it for every light. So hopefully that makes sense. You could do that with any texture, and that's basically how all of these work is you just make a picture, make a top, and you go top to chop and sample it with your UV positions, which again is important why these have to update everywhere if I change them. So if you understand that, the rest of this will make sense for the most part because dimmer is exactly the same, but just without color. It's just using the alpha, for example. I mean, there's a couple UI things here, like this is like, I didn't put them in separate components because I just wasn't organized enough. But imagine this is a component that says like all for one, so it's just a constant. And this is a component that says like ambient mode, and you have this switch. And this is my flip direction button, uh, where you see it's just multiplied by whatever this chop is, either one or -1. And I guess to make that happen, I used a panel execute and said when it's on, it's 1. When it's off, it's -1. The dimmer low bound was to go. Oh yeah, I figured out how to use F string. So this was along the way of the project. I started picking up the Python tricks. Instead of having to go through each ramp individually, you could use a loop and just reference the number of it. Uh, but yeah, that's the idea. Is I could change the ramp value automatically. And if I did it again, I would add a high bound as well, which would be as simple as this. I would just change this to 0 and add another constant here. And that's all you would have to do. And then add it, add the multiplication inside the ramp. But that's all that is. Same concept of using the filter and back, and then multiplying it by my UV positions to get my previs, and coming out of here as a top. And these, since color and dim work together, I added them to their own previs so that it would be RGB and A emulating color and dim. So that this is basically just previs. Like again, if I did this again, all of this would be like labeled correctly and positioned so that everything made sense. It's a big like web of sort of nonsense right now. Pan and tilt. I did not use this top previs idea uh, because there would be no interesting previs of pan and tilt without using 3D. So that would be way more complicated for this section than it would have needed to be. And I was like, well, you could just literally have sliders changing the value that you want to change, 0 to 1. And so that's all that is. Same thing for tilt, just literally a constant with sliders where the output is from 0 to 1. And then how you format it correctly is you merge them together. Um, I reordered them because, well, this is very niche unless you like have to work with this in the future. But these pan and tilt are going to be ordered like this, where all the pans and all the tilts, and I want them to be arranged like what the light is together. So pan tilt, pan light one, tilt light one, pan light two, tilt light two. So yeah, reorder them, and then you switch uh, you sequence every second channel so that all the pans are in one channel and all the lights are on the other channel. And now that I'm thinking about it, I maybe could have just switched to this and had NB10. I'm not sure. So other caveat here is that the first 9 lights are spotlights. They don't have pan and tilt. So see, I only have 10 here, but for my data to be formatted, it has to be a one long channel with all 19 lights on it, because each light is later going to be referenced by its sample number. So I have basically a blank pattern here for the first 9 lights, uh, so that all of these will now start after 9, and you just join those together, rename them, and then I'll show that later. But that's pan and tilt. Frost, where it's exactly the same as everything else. It also has all these rectangles and the update positions. And it just uses, since it's on and off, it just uses alpha for the frost channel, and works exactly the same. Comes out as a top. Switch it to chop and come out here. Prisms work exactly the same. There was an on and off. Only difference is uh, if on and off is alpha, then I just made rotation, I think the blue channel. So also not a very interesting previs, but doing it in this case, since there's 2 values, it's simpler to do it with a top than uh, with the chops like this, because I can reference reference two channels off the same top, like so. So yeah, hopefully you get the idea, because everything else looks exactly the same. Uh, Comes out as a top, switch it to chops, make sure all the samples line up, give it a name, and send it to this merge. I will. I'll talk about the final formatting and then come back to this, because this was a very specific to this project, which is very annoying. But once you have all of your channels, however many things you want to control with your lights, you merge them all. Um, and let me think. So you have each of these now, you have a channel for all of the red channels, like a channel for all of the green channels. But what you want is each light to have a channel. And uh, sample one is, or I guess you could do it either way. This is just how I wanted to think about it. Was I wanted the sample number to be the light, and then grab its red channel, or reverse of that. And so shuffle it into switch the channels and samples. And I guess that is a reason why I wanted to. do this was just to fit my like naming convention of like half of the lights are called spot and the other one are lights to keep track of which ones move and which ones don't. And so now I have now I can reference the light by name, and I just keep track of like sample zero is R and sample one is G, and I can reference that later when I'm actually controlling the lights. So that's all it takes to format the data. And now this weird thing over here that I wouldn't recommend. So basically, half of the lights they used a color wheel gobo instead of RGB. So I couldn't actually tell it RGB channels. I had one channel that said to select a place on this color wheel where there are set colors. And trying to think of where these were coming from. Oh yeah, I selected the RGB from up here. So I use the same colors. Like I want to use these colors, um, but down here, I guess let me just explain these scripts. And I'll be honest, I had to use ChatGPT to try and figure out a method here. Um, Essentially, what it's trying to do is to estimate where on the wheel should I be based on my RGB channels that I'm seeing. Uh, and I tried one method before, and then I asked it what's a better way to do it, and it said basically use it like an HSV thing, sort of lookup. And I'll also say like the only reason this works is that the in the manual of the light it tells me what each color is, so I can tell it like oh, well light zero is white, light one is red, and we'll try to figure it out from there. So yeah, since that's mainly a ChatGPT thing, I'm not going to waste time trying to explain how the script works. But the only important thing is that the output of it comes to this channel, comes to this dat table. So these are like uh, the DMX values of the color wheel channel, uh, estimated based on the RGB values, basically trying to convert RGB to color wheel, which did not work perfectly, but still had a cool effect. Uh, and yeah, adding some filtering to it because it's very jittery. Because imagine yellow is over here and green is over here, and you want to blend from green to yellow. The number value difference is like from 50 to 200. So it jumps between everything. It was not a good system if you wanted accurate colors. I don't know why um, a nice light with so many other features would use color wheel instead of RGB. But basically just tack that on to my data as the last channel. And I'll show you in the control script when we make it to the com section that I just didn't reference RGB for those first channels, even though I have their values. I just referenced color wheel for it. That's all it is. Um, so yeah, I think I explained everything. The main concept is just sampling UV positions in a top to chop situation. And then you could just, you have RGB and A values. You could just use those values for anything. That's why there's like renames and things. And then after that, it's all about how do you want the data formatted for yourself when you go and use it later. So I believe that's all there is to explain there. And that is the light section of the colors. Yeah, this is how the lights, this is how all of the like data for how to control the lights was generated right here. Still going over the Nashville Drone 2025 project. Moving on to the Gen section, the video section of Gen. This one will also, since I don't have the cameras connected, you won't see the details, but uh, with top stuff, it's kind of not much rhyme or reason, honestly. Uh, this one was a video switcher. Uh, so this was one of the camera feeds. This was the other camera feed, and then you can switch between them. That's all it is. And this was a flip, so it was like not mirrored. It would match what you were doing. So this is all it is. It's just the video in, and then could switch between them. The effects is where I'm like, there's not really much rhyme or reason. When you get into like a top rabbit hole, you just start stacking effects. And so this was like video in, fit it to my aspect ratio, and then I was like, oh, let me try and remove the background. And honestly, during the event, like I had like a setup, but I made this setup like at home, not under the same conditions. So when I was, and also the event was 6 hours, so the like presets that I had saved got stale after a while. So most of this, or a lot of this, is like I ended up like adding things to it while like during the event. So that's why I'm like, there's not much rhyme or reason or anything to really break down here. It's like I just connected a bunch of stuff and messed with the composite modes and things like that. Yeah, so a lot of this was like I just started adding stuff on site as well. Um, I guess the thing relevant to the UI is this was the video switcher you saw. These were connected to the background removal component because they were heavily reactive. Like everything else down the line, since this was at the beginning, everything else down the line was very reactive to what happened here and how I removed the background. And then this was like the main composite out, and I wanted to like save which ones were the cool ones here. So I made just a little switcher top between like which ones were the cool ones, and that's what these were. So that's the only relevant thing to the UI. If I could do it again, honestly, I don't even know what I would do differently. I didn't really make use of this the way I thought I could. Um, or maybe I would have added these LFOs in the first place, or maybe I would have just given myself way more options just in the UI to be able to switch between uh, to make it just that much more options for on-site. But besides that, I was happy with it. It looked good, especially since the out of this was going to VDMX for extra processing. That's what really brought it together most of the time. So yeah, that's really all there is to it. Video switcher to effects, and then the effects out is just a top sort of rabbit hole of stacking cool things on top of each other. So yeah, that's all there is to it. Still going over my Nashville Drone 2025 project. We're moving on to the comms section. So for this project, uh, we had video in, out. We're not going to go over audio because I ended up not making it audio reactive. But then we also had OSC going and DMX going. So most of this is simple, and then the DMX out will be the more interesting part. We'll start with the video in. This is where the Raspberry Pis came in. So I'll probably end up making a separate documentation about how those Raspberry Pi cameras work. But basically, from the TouchDesigner perspective, all it needs to know is that it's receiving a video stream over the network. And so you have a video stream in top, and you just need to, and the Raspberry Pi is the server. Uh, and so it needs to just address the IP address of the Raspberry Pi and the port that it's on. And so on the Raspberry Pi, I uh, gave it a host name so that instead of having to find the IP address, I could just call it pi.a.local. If you didn't do that, you could still just go into the Pi and find its IP address and put it here. And in the program that runs the server, it just also specifies the port. So I just also know what the port is already. Um, but that's all it is from this side of the program is just a video stream in top looking at the correct Pi. And then I messed with some of these settings to try and get the latency as low as possible. Uh, but in this case, the latency wasn't a massive problem. There probably is a better protocol for true low latency video over the network. Uh, and in case anyone's wondering why I didn't use NDI, because NDI actually did work amazing for other things. I just couldn't figure out how to do it on Raspberry Pi because the when I looked into the NDI, I guess SDK, it doesn't support Linux. So I didn't think they would work on Raspberry Pi, but maybe there's a workaround. So that's it for video in. I guess I don't have the cameras hooked in, but basically as soon as you plug it in and they start streaming, it'll immediately get picked up by the video stream in tub. And then video out actually was NDI. Part of this project, I had my friend sitting next to me, and he was using a program called VDMX, um, which is I guess it's like a similar concept to TouchDesigner, which is like a video visual program that's like interoperable with a bunch of things, but it seemed mainly optimized for like video synthesis ideas. And the whole point of this was just I'll have a camera, I'll do some top stuff to it, and then I'll send that out to you over NDI, and then you could do even more processing of it. And so that's all this was NDI out to his computer. And NDI actually was like extremely simple, massively low latency, like amazing protocol, worked instantly. Yeah. And OSC, we actually ended up not using this either. We were using it in like testing and planning that it might be cool if I could send him the same like DMX signals that are going out, and he could attach them to some of his knobs and sliders and things. But VDMX didn't have such a graphical interface as TouchDesigner. Like I expected him to get something like this where he could just grab a thing and attach it to something. But it did not work that way. So we ended up not really connecting our systems in that such a direct way. And we even tried OSC in from him so that maybe he wanted to mess with video slider knobs and things, but decided against that as well. Uh, so really, it was just video comms and then DMX out comms is the main thing. Um, so let me start by actually let me work backwards because that actually makes the most sense because what we know is that we're trying to have a DMX out. And so we know DMX has 512 channels. And um, even if you don't, like, for example, if the venue didn't even have things on all 512 channels, but the thing I want to control is on channel 500, then I still need a bunch of Blake channels in order to reach channel 500, which is the one I want to move. So you still need to give this thing 512 channels ultimately. And I had a Intech USB Pro interface, which is like USB out of my computer to DMX. And I found out that it does have to be the Pro because I got the not Pro version before, and uh, the driver, I guess, didn't work. So a little stressful there, but ultimately did find a box that worked. So you have DMX out ultimately. This shuffle was optional in case I wanted it to be packet per channel instead of sample. It was just a part of a debugging thing to figure out if one was better than the other, but ultimately didn't need it. And this was helpful to keep double checking if I had 512 channels, because at some point, when I show you these blank channels, I was using a replicator and then I changed something and I didn't realize that all of my clones got disconnected. And I was like, why is nothing on the right channel? I didn't have 512 channels going in. So yeah, so how do these blank channels work? How do you like format the data to be sent out over DMX? Well, this is just for this particular project, for this particular venue. I just have a sheet of what everything is on. And so I gave myself this sort of thing to keep track of where I was. Like the first 49 or 50 channels technically are blank. And like I'm not going to be controlling those. So all you do is make, constant shop, uh, replicate it to as many ones as you need, and then fill in the extras just to get however many blank channels you need. Throw that into a merge, and then the ones that you do want to control, you give those the actual parameters you want, and then I also replicated these to however many I had, and then I just attached them to custom components on this parameter. So basically, this is one of the when I first started making this project. This is actually the first thing I did because I just knew this is going to be the output of whatever else I do in the project. So I just thought like, okay, if I just have these custom parameters for and name them for what I want, then whatever else I do in the project, it just has to come in here and move these parameters, and those are being sent out over DMX. Like that's all it takes to like format the data is just these sliders go from 0 to 255. They're named for what they are. They're on the correct channel of what they control. And so just move that slider and it gets sent out. And that goes through all the lights. I had 9 spots and then a bunch of blank channels. And then this was one type of light, and they have their channels, and then more blanks. And then the other type of light, they have those channels, more blanks, and then a fog machine. I mentioned earlier that one of the headaches of this project was that there was 3 different types of lights. So the spots only had these controls, and then even though they were both moving lights, there were 2 different types of moving lights. So they worked differently and only had some of the same controls. And importantly, I mentioned in the lights gen section, these lights, as you can see, if you look closely, they don't have anything that says RGB. They just have this color, and color is a static wheel, basically of gels. It had like 7 colors on it, and I didn't realize this until I was, writing this script of like, wait, I don't see RGB, and so yeah, I had to do that. I showed you in Gen. I had to do that conversion from RGB to color wheel, which again, it looked cool on site, so I'm not mad at it, but it is weird, and it definitely didn't work perfectly. Like if I needed this color to be yellow, it was not going to be yellow, you know. So yeah, this was important to frame the rest of the project of just knowing what are the channels that I can control and actually just setting up the 512 channels at the beginning so that so whatever else I do, it just has to come out over here and move these nodes. And then how do I actually do it? So out of the gen section, remember, like the final formatting was just every light has a channel and each sample represents like the thing that I want to control. And I just have this script. So the reason why there's 2 scripts here is because on site I realized I might want one version that controls the one version that like automatically controls the spotlights from the generation, and one version that does not control the spotlights so that I can manually control them. And that that was honestly just poor planning on my part about not being able to engage manual control over individual lights. I feel like a real lighting controller, I think, would let you do that. And here was just whatever automatic program is running, that's what the lights are going to be doing. And so I can't really touch individual lights if they're being controlled by something else. But this is the main script I can get into. Uh, I would pull up the code editor, but my OBS is only looking at TouchDesigner, so I really wouldn't see it. But yeah, basically, this is just a select chop, and this I believe is a chop execute. Yeah, just a regular chop execute that looking at every channel. And so I gave myself some helper names, like I named the lights for what component they're going to be on. So yeah, for example, this S12 or S712, it only has these lights on it, right? And the other one has the other lights on it. Um, so give myself these helper variables, and then it's going to be on value change. So if anything changes, let's start looking at these. And then I told myself this is what each sample represents. Just give myself the key. And so the reason why I wanted each channel to be named uh, by the light, and again, you could do it either way. Like instead of saying if the channel is spot one, I could have said if the channel is R, and then gone by light. So you could do it either way. But this is just how my brain was thinking about it. And this is how they all work. It's just if the channel is the light, so whatever the light is, then what's the sample index? If it's zero, then change the red. If it's one, then change the green. And it goes on like that for every light, just depending on whatever options that light has. Like obviously some of them have the spotlights didn't have pan and tilt, the one type of light didn't have RGB, but whatever it had, I just brought in the data and said, if it's this light, then what sample is it? If it's that sample, then move the correct knob over there. And that's really all it takes. Um, like I said, this other script was the same thing, but I deleted oh, you can't see. It's the same thing, but I deleted the spotlights so that they wouldn't be controlled. Yep. And I think there's not really anything else to explain over here. Yeah, all of these are just constant chops. Oh, I guess here's an interesting tool. Almost forgot about this. Um, Once it got to this, where I was like, this light has uh, like 29 channels or something like that. Do I have to go through and manually bind 29 channels multiple times? And I started thinking about how you could script things. Like this was really the beginning of realizing that I could use F strings and script parameters and bindings and things. And it's just things have to be named correctly, and there's little quirks, so you have to sort of plan it out. Um, you have to sort of plan it out consciously and intentionally. But this, I wrote it up here, like this is not part of the live program. This is just during the building. I run this once, and it'll bind all the parameters. Uh, Again, in the future, I think I'm gonna like be more organized and put all of my scripts in a place uh, so that I can debug very easily. Yeah, you can see I had to write a different script for this one. Um, yeah, bind custom parameters. But that was a useful tool once I figured it out. So yeah, I believe that's it on the comms section. Didn't use audio and really didn't use OSC, but had the options to.